sure my audio is actually on. So there's two terms. If it's binomial, it's two terms. A plus B makes it be two terms. So this is a binomial. A trinomial would be if it was like A plus B plus C. That would have three terms. So binomial theorem, we can expand something of the form A plus B to the n way faster than actually having to expand it out by hand. So if I have like x plus 3 cubed, yes, I could write it as x plus 3 times x plus 3 times x plus 3 and expand that all the way out, but that's really, really tedious and there's a lot of algebra mistakes that you can make. So the binomial theorem helps us avoid that. When we're expanding this out, we get x squared plus 3x plus 3x plus 9, which simplifies to being x squared plus 2 of the 3x's plus 9, which is really x squared plus 6x plus 9. I'm making a point for the 2 because this is going to be part of the binomial theorem. Then we can expand out x plus 3. Long way would have been saying x plus 3 times that x plus 3 squared we just got. And you're like, okay, now I'm going to multiply x times all of those numbers plus 6x squared plus 9x. And then we're going to multiply the 3 times all of the numbers. 3 times x squared plus 3 times 6 plus 3 times 9. And we combine like terms. I like to add vertically. That's why I'm like putting it underneath it. So we get x cubed plus 9x squared plus 9 plus 18 is 27. X plus 27. So when you're doing something degree bigger than 2, so like 3, 4, 5th degree, the expansion gets like really obnoxious to deal with. So these two mathematicians came up with binomial theorem using Pascal's triangle. So Pascal came up with the triangle, and then I don't want to butcher their names, but they came up with binomial theorem. So this is binomial theorem. It looks a little crazy. This is really, this symbol here means a combination. So let's write what that means. Do I have that formula written anywhere? I do. It's on the next page. But NR is really the same thing as NCR. It's a combination. And there's a formula, n factorial over r factorial times n minus r factorial. The NCR is what you can put in your calculator. There's a lot of n's. It's an exclamation point. So if we have an exclamation point at like 3 factorial, it's not just like a super excited 3. It's actually like a mathematical operation, factorial. It'd be 3, and then you just, whatever number you have, you start there and you multiply by the integers until you get to 1. So this is 3 times 2 times 1. So if it was 4 factorial, you'd have 4 times 3 times 2 times 1. So in this situation, r is 0. Oh, and also, just so we know, 0 factorial is equal to 1. I have a proof for it, but I don't think you actually care. So here is the formula, but really I think we could just use Pascal's triangle. So first glance, the binomial theorem looks like really complicated, but it's actually super easy to do once you get the gist of what you need to do to expand it. When expanding the binomial expression, the first term in the parentheses, which we're saying is a, that's the first term in the parentheses, begins with whatever degree the parentheses is 2. So like we're saying, oh here, A is to the n power, and then the B term is multiplying A, and it's going to be to the 0 power. So that's why there's, in this first expansion, there's no B, because what's anything to the 0 power equal? 1. Then, as we go, the A term decreases by 1 for each term. So between every plus sign decreases, the exponent decreases by 1. And the B term increases by 1 for each term, until B is to the degree of n. You know that you have this written correctly as long as the exponents for A and B add up to whatever n was. All right, so Pascal's triangle. In Pascal's triangle, you start with a little triangle of 1. So do you see the triangle? And all the sides are always 1. And then the term above it that isn't, we add the numbers above the term. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. So the pattern continues as you go down. 1 plus 3 is 4. 3 plus 3 is 6. So you don't really have to memorize the whole triangle. You just have to know how to derive it yourself. The values of n and r correspond to, r is the element number, so what spot in the triangle we're on, and n is the row in the triangle. We start with row 0. So this is n equals 0. This is n equals 1, n equals 2, etc. So n is the degree of the outside. So if we have a third degree, we would be looking for basically the one that has 1, 3. If we had x plus 2 to the 6th, we'd be using the row with a 6 in it. So that would be the 6th row. So if you're trying to figure out what the r's are, the term number, this spot is the 0th spot. 0th term. It's the initial term. So in the initial term, you usually use 0 instead of 1. So that's just like this is the initial row, it's 0. This is the initial spot. This is the first spot. Second, third, 4, 5, 6, 7. But how many terms total did I have? I didn't have 7. Right, there's 8 terms. So there's always one more term than the number that you were taking for the degree. Okay, let's try to do one on the next page. So this is just trying to take and have you figure out the combination thing. So if I said 5, this is red, 5, choose 2. Down here, 5, choose 2. We're going for the 5th row. Remember, we're starting at 0. Or the row with a 5. And then go 0, 1, 2. So that's why 5, choose 2 is 10. This is 0, initial term, 1, 2. So I want you to try to find 6, choose 4. Yes. 6, choose 4. So go to the 6th row and then the 4th element, which remember we're starting at 0. So this is the 0th row. 1, 2, 3, 4, 5, 6. So you should be looking in the row that goes 1, 6. And what do we get for the 4th term? Angus, what'd you get? 15. Let's see. 0, 1, 2, 3, 4. Yes. Let's do another one because I feel like some of you are still a little like, I don't get it. Do you also notice that 6 choose 2 is also 15? Right? 0, 1, 2. It's also equal to 15. They do have symmetry. Pascal's triangle has symmetry. And it's because if you had started from this direction, that would have been the 4th term. So there is symmetry. Let's do one more. Ooh, we don't have this row. How will we create it? I want you to create the 8th row. Follow the pattern of adding. You could be writing on a piece of paper. So when we create the 8th row, we only have to go to the 0, 1, 2, 3, the 3rd term. But we could do the whole row just so you know how it's made. Start with a 1, and then these two add together. 8. 7 plus 21 is 28. I feel like I smell fast food. 21 plus 35 is 56. 35 plus 35 is 70, and then we got, it's the same thing back down. Yep.
I'm kind of also like how this, like, I understand like the whole expansion part, but like.
We haven't expanded anything yet. We're just trying to figure out how to get the terms when we do expand it.
Okay, so when it's like n over whatever.
Yeah, this is just figuring out what the n over number is. All right, so 3rd term, what is the 3rd term going to be? 56. All right, so let's expand x plus 2 to the 5th. We haven't actually expanded a binomial. Think about if you were to do x plus 2 to the 5th by hand without binomial expansion, that would take a really, really long time. And you would probably also mess up some of your multiplication and whatever. So this is the usefulness of binomial expansion. Using Pascal's triangle. If it is to the 5th, what row are you taking? The 5th, or, well, yeah, 0, 1, 2, 3, 4, 5. So the one that's already pre-circled in the notes is the row we're taking. So write that down, really spread apart. 5, 1, 5, 10, 10, 5, 1. So that's coming from that already circled row. The A term starts with the degree outside the parentheses. X is going to be to the 5. And then that descends in power. So the next one is going to be to the 4th. You don't really need parentheses in this case. I just like to do it because, like on example 2, the 2x is going to be all to the 4th. And then the 3rd and 2nd and so on. I think when we start off and then when we simplify, you don't leave it like that. Okay. The other thing about the 2 is going to be to the power that, well, 1 starts at 0, but also the exponents between these two should always add to whatever the degree is out here. 5 plus 0 is 0. What do we think 2 is going to be in the next term? To the first, and then to the second, then to the third, then to the fourth, and finally to the, oops, I changed it to a 3 all of a sudden. That's awkward. 2. I think I said to the third as I was writing the 2 and just wrote 3. So let's simplify this. Oh, and we need plus signs. We have 1 times x to the 5th times 2 to the 0 leaves us with x to the 5th. 5 times x to the 4th times 2 is 10 x to the 4th. 10 times 2 squared, what's 2 squared? 4, so we're doing 4 times 10. 40 x cubed. Trying to write them underneath the terms so you know where I'm getting it from. 10 times 8, this is not a 6, it's not 2 times 3, it's 2 to the third, so it's 2 times 2, 4, times another 2, 8. So we have 80x squared. Okay, this one's going to be 16. 16 times 5, 80, I believe. And then 2 to the 5th is 32. I want you to try to expand out number 2. What row will we have? It's multiplying, just like how we had 5 times 2, right? Like, so it's just like it's part of the multiplication. And then -1, this is the, yeah. The next term's going to have all of 2x to the less. Not 2x. Yeah, all of a sudden you have a very different thing that you can substitute out. All of the 2x's in there. So a term is 2x. So 2 and an x. I don't know that. 2 is and then the -1 is the first power. It's going to be plus and this is a minus. No, this is a -1. I would guess. And so that's how you can figure out what the signs are going to be doing. Close. It's the last term. Yes, and all the terms are wrong. It's you'll see why. So when we expand this out, we should have picked the fourth row, which has 1, 4, 6, 4, 1. Most of you did that part correctly. The A term is all of 2x. So all of 2x is to the fourth. All of 2x, so the 2 and the x are to the fourth. Then all of it is cubed. All of it is squared. Seconded. Ooh, firsted. Okay, and then the B term is -1, not just 1. So you have -1 to the 0. -1 to the 1. -1 squared. -1 cubed. -1 fourth. So you know you've done this correctly when the degrees between each term are adding up to whatever the degree is outside the parentheses. You know you have a mistake if you add it up to like 5 or something. All right, so let's simplify because some of you did not make all of 2x be to the fourth and then you didn't have the right answer. And some other ones of you didn't put the -1 in here. These are all multiplying each other. So what do you think the pattern is going to be? Is this first term positive or negative? Positive, because -1 to the 0 is 1. But then -1 to the 1, what's going to happen? Negative. And then what's going to happen here? It's being squared. It's positive. So what's the pattern? Right. It always starts positive, and then it's going positive, negative, positive, negative. So anytime you see a negative in the parentheses, that should be the pattern. You should see the signs flipping between positive and negative. All right, 2 to the fourth is 16. 2 to the third is 8, but it's times 4. Oops, and it's minus. So we have 32x cubed. 2 squared is 4 times 6, 24x. Ooh, I put 26. What is going on with my brain today? 24x squared. And then minus 4 times 2 is 8 plus 1. My favorite types of questions to ask on a test, especially multiple choice, is to give me the coefficient of the whatever degree term. Either I'll say x to the fourth term, or I'll be like the third term when we expand it. So example 3 and 4 are kind of like definitely test style questions. When we don't want to have to expand this whole entire thing out. I don't want to waste my time. But you could start out with at least the shell of it. So if I'm doing x plus 5 to the 6th, what row should I be doing? The 6th row, the one with the 6. So you have 1, 6, 15, 20, etc. And we're trying to figure out the x to the 4th. So if I put this first term in there, x, I would start to the what power? The 6th power. So I'm starting to the 6th. Then I'd have 5, 4. You can also just count and be like 6, 5, 4 and only have to have that term. And then the other number was 5. What power is, oh my gosh, what power is 5 going to be to? How did you know it's going to be 2? Right. These two numbers have to add to whatever degree is out here. So those are adding to 6. So we really have the coefficient is 15 times 5 squared, which is 25. That's fun. 375. Try to do example 4. Cubic term. Well, if it was a multiple choice, it would only have the numbers. But for your response, yeah, I'd be like, -1. Do you not know what a coefficient is? Probably no calculator. So the numbers aren't going to be like astronomical. This one's pretty high. This one, maybe you would need a calculator for, but at least leave it with whatever numbers you get. So we have the cubic term and the 8th row. We already wrote out the 8th row. So it would have been 1, 8, 28, 56, 70, 56, 28, etc. And then this would have been x to the 8, 7, 6, 5, 4, 3. So I'm taking 56. And then so this is the spot I really care about. And the 56 is multiplying -3 to what power? Yes. So you should at least be able to say that 56 times -3 to the 5th would have been the coefficient if you didn't have a calculator. But fun fact, -3 to the 5th is -243. And that simplifies to be -13,608. You also could have done, and if you had a calculator, you could have done 8, choose 5. This number here, or like 8, choose 5. How did I pick out 5 and not 3? Right, 8 minus 3 is 5. So whatever the degree is here, this term is like 8 over the degree. Well, the 8 minus the degree. So that's how you could like figure out without Pascal's triangle if it's huge. Now, I don't know if Desmos does combinations. I feel like Desmos would. I've actually never tried it. I've only tried it on 84s. I wonder. Desmos is so good. Choose. Oh. That's not it. But it should be a subscript. What is it doing? I might have to Google it. I don't really know how to do function. All right, I will figure it out how to do it on Desmos. All right, on your classwork, I think you could do this whole page. I feel like all of them are super good questions. But let's do 1, 2, 3, 5, and 7 is so easy that you'll do it in 5 seconds. 1, 2, 3, 5, 7. So almost the odds, but include 2. Ask Google. Okay, I figured it out. So Desmos says you have to type it in N, capital C, lowercase r, and then put the ordered pair of like N, comma R. Well, let's write that on our notes. If you were using a calculator. So you could try this tonight. The parentheses, the numbers that you're putting in the parentheses is like whatever n and r should be. So for example, we would type NCR 8, 5 and would have gotten 56. Just a little quick Google. Got me there. Yeah. Okay. I do think we could go over the test today, so if we could finish our classwork quickly, that would be good.